Linear regression. The equation of a line review. Y equals mx plus b. M is the slope and b is called the y-intercept. Example 1. Use the equation y equals 2x plus 3. Make a table for x and y using x equals 0, 1, 2, and 3. To get y, you plug in those numbers for x. Plug in x equals 0. 2 times 0 plus 3 equals 3. X equals 1. 2 times 1 plus 3 equals 2 plus 3 equals 5. Plug in 2. 2 times 2 plus 3 would be 4 plus 3 is 7. Plug in 3. 2 times 3 plus 3 would be 6 plus 3 equals 9. Example 1, I just recopied that from the last page. In the equation y equals 2x plus 3, the slope is 2. The slope is the rise over the run. It is the change in y divided by the change in x. The slope of 2 is understood 2 over 1. That means y increases 2 every time x increases by 1. Notice the y values increase by 2 for each new x value. The y values are 3, 5, 7, 9, and would continue. They go up by 2. A positive slope means x increases, y increases. This would be a positive correlation. In the equation y equals 2x plus 3, the y-intercept is 3. The y-intercept is the value of y that you get when you plug in 0. You can see when we plugged in 0, we got 3. Example 2, let y equals negative 3x plus 1. Make a table for x and y using x equals 0, 1, 2, and 3. Plug in 0. Negative 3 times 0 plus 1 equals 1. Plug in 1. Negative 3 times 1 plus 1 is negative 3 plus 1 equals negative 2. Plug in 2. Negative 3 times 2 plus 1 equals negative 6 plus 1 equals negative 5. Plug in 3. Negative 3 times 3 plus 1, negative 9 plus 1 equals negative 8. We can see the slope is negative 3. That's the number in front of x because it's mx plus b. This is understood negative 3 over 1. As x goes up by 1, y goes down by 3 because it's negative 3. And you can see the y values, 1, negative 2, negative 5, negative 8, are getting smaller by 3 each time. This would be a negative correlation. As x gets bigger, y gets smaller. The y-intercept is 1. When x equals 0, y equals 1. Linear regression means taking a whole bunch of points and making the line of best fit. The line of best fit is the one that minimizes the difference between an actual value and the predicted value. The scatter plot must show a linear pattern for the points. We're using data to make a prediction for other values. For example, if you see that tuition has been rising $500 each year, you could take the last year's tuition, add 500 to guess what next year's tuition will be. If you look at the age of a car and car values, you might notice that the value of a car decreases. Y hat, Y with a little triangle over it, means the prediction equation. Example 3. Given a regression equation, predict values. A golfer takes 8 swings with a golf club. The speed of the club head, miles per hour, and distance the ball traveled, in yards, is measured. A regression equation is found using technology. Speed is x and distance is y. If the regression equation is y hat equals 3.1661x minus 55.7966, estimate how far a golf ball would go if speed is 103 miles per hour. Round to tenths. Okay, so the regression equation was found using technology. And estimate how far for 103 means plug in 103 for x. So multiply 3.1661 times 103 and subtract 55.7966. And you get y equals 270.3117. Round to tenths, the ball is estimated to travel 270.3 yards. The value of 270.3 is a prediction value. We cannot 100% predict the future, 100%. A residual is the difference between an actual value observed and the predicted value. Residual equals observed, actually happened, minus predicted, y hat from the prediction equation. Okay, we're seeing how accurate our prediction equation is. If the golfer swung with 103 miles per hour and the distance actually traveled was 274 yards, then 274 is the observed value. This actually happened. So the residual equals observed minus predicted equals he actually hit it 274 yards, he or she. Subtract what we predicted with 103 miles per hour from the previous page was 270.3, and we get 3.7. Since the observed value, 274, is higher than the predicted value, 270.3, the actual swing was above average, better than predicted. Part C. If the golfer swung with 103 miles per hour and distance actually traveled was 265, then 265 would be the observed value. That actually happened. The residual equals observed minus predicted. Observed is 265, what actually happened, minus predicted, 273 from the equation, equals negative 5.3. Since the observed value is lower than the predicted value, the actual swing was below average. Interpret the slope of 3.1661. Each increase in 1 mile per hour results in an increase of 3.1661 yards. It does not make sense to interpret the intercept. The intercept means when x equals 0, that is y. You cannot have a swing of 0 miles per hour because x is how many miles per hour the golf club swung. Example 4, find a regression equation with Excel. Step 1, type in the data. Here's an example of years since 2000. So column A is how many years since 2000, and column B is the tuition. Let's see if this scatter plot appears to be a line. So drag and highlight the data, click Insert, look at Charts, select Scatter Plot, and click Scatter Plot. We can see that it does appear to be a line. Tuition rises as years increase. Step 2, click Data at the top right screen. If you see Data Analysis on the right, proceed to Step 3. Otherwise, click File in the top left, and then Options, which is all the way at the bottom. Select Add-ins in the left. Click on Analysis Toolpack, and click Go. Then checkmark each item and click OK. Step 3, click Data at the top, and then Data Analysis at the far right. Scroll through until you find Regression, select it, and hit OK. Click in the box that says Input Y Range. Drag and highlight the second column. Click the box that says Input X Range. Drag and highlight the first column. Click OK. Notice you will have a new sheet. Look at the bottom. This is where your answers are. Okay, and I've circled that. You're looking under the coefficients, intercept, and x variable 1. Okay, that's the same page. Under coefficients, this means the equation is y hat. The slope, the thing that goes in front of x, is where it says coefficient x variable 1. And the intercept is where it says coefficient intercept. X is the number of years since 2000, and y is the predicted tuition. It goes in the form y equals mx plus b. Slope is M, found under X variable coefficient. B is found under intercept coefficient. So y hat equals 398.127x plus 3432.527. Example 5. In MyMathLab, we will see how to use another technology if you do not have Excel. This is called StatCrunch, and it is built in your homework. This time, when you click the box, choose Open in StatCrunch. The example below tries to predict final grade based on number of absences. So X, absences, grade Y. First, let's see if the scatter plot appears to be aligned. In StatCrunch, click Graph, choose Scatter Plot. In the drop-down boxes, select X and Y, and click Compute at the bottom. We can see that it is aligned. It appears that grades fall as absences increase because it's going down, and it looks like a line. Now we will find the equation. Choose Stat, Regression, Simple Linear. Select X and Y in the drop-down boxes. Click Compute. This tells us the prediction equation is y hat equals negative 3.14x plus 88.27. Note that StatCrunch wrote it y hat, grade, equals 88.27 minus 3.14x. Those are the same thing. Number of absences after the negative 3.14 circled there means negative 3.14 times the number of absences, which is x. These are the same thing. X is the number of absences, y is the predicted grade. Okay, so you can use your equation to predict grade based on absences. The negative 3.14 means that absences increase and y grade decreases. That's the end.